Okay, good morning, ladies and gentlemen. I hope you're enjoying this turbocharged amphibian action-packed session, and I hope I can keep you glued to your seat with my talk on passive acoustic monitoring in the Ndumo Game Reserve. Okay, just a short introduction on conservation of biodiversity. What is conservation? Conservation is the scientific study of the natural environment or biodiversity, and with the aim of protecting species, habitats and ecosystems from habitat destruction or extinction. And the question is, why should we conserve? Because if we conserve biodiversity and the environment, this is the basis of all life on Earth, and removing one species definitely has effects on other species, except in the case of human beings. If you remove humans from a natural system, nothing else happens to the rest of the diversity or animal life. It just carries on. So that's just something to think about. And then how to conserve. There's different methods that can be used. In situ conservation is when you're looking at a specific species in its natural environment, and ex situ is when you're taking that species out and you're trying to conserve it in a lab setup. And then you also can conserve flagship species, such as the rhino, where there's a massive focus on a certain species, funding comes in, and the ultimate is if that species helps preserve and umbrellas other species. And then also keystone species. Then why conserve amphibians? This is the most threatened vertebrate class, and it's a very diverse group. And currently, as Adrian mentioned, over 7,300 species, and this is changing all the time with the scientific focus on this class, with new species being described and discovered all the time. Amphibians are also an indicator species with its permeable skin and amphibious lifestyle, as well as a keystone species, fitting in the middle of a food web. The illustrations that just show that frogs eat large numbers of invertebrates and are also prey to different vertebrates such as snakes and birds and even other frogs. So in southern Africa, we've also got quite a diversity of frog species with 13 families, 33 genera, and 159 different species. This could be due to the diverse habitat and ecosystems. And in the KwaZulu-Natal province, the tropical climate is preferred for many different amphibian species, and this leads to being the highest diversity of amphibian species within southern Africa. Compared to the Western Cape, where the unique floristic region has a number of different microhabitats, and this leads to the most or the highest number of endemic species found in this area. And here you can see that the map just showing that the diversity increases along the coast up to KwaZulu-Natal, and the endemic species go down along to the Western Cape province. Okay, then just the basics of conservation. First, you have to know and understand the subject that you're working on and why you want to conserve the subject. So these are important questions that you have to ask yourself and put into your planning before starting a conservation project. And then you can gather different information through published literature, but that's not always available, and the alternative to that is to physically go out and monitor the place that you want to conserve and the species that you want to conserve. And there's different types of methods that can be used, or monitoring methods, such as active monitoring and passive monitoring. Then active monitoring, this entails visual encounters as well as sampling of specimens, dip netting for tadpoles and xenopus, as well as acoustic surveys and scoring. This is utilized when you're at a site and you listen for as many different species, and then you score them out of 5, and this can help you determine the abundance and intensity of the species. Then passive monitoring, you can make use of drift fence and pitfall traps, baited bucket traps, and bottle traps. And these are specifically used catching xenopus, the aquatic species, as well as tadpoles. And then a relatively new approach, Donovan went in quite a lot of detail, passive acoustic monitoring, PAM. And this will be what I'll be focusing on for the rest of the presentation. Okay, the outline of the study. This research that I'm talking about now just formed part of my MSc, so I didn't go into too much detail, and I just want to, we're just using this as a pilot study to compare passive acoustic monitoring with traditional surveying monitoring methods. So we selected a temporary pan in Ndumo Game Reserve, and we used traditional sampling methods, so, as I mentioned before, and this took place over 5 sampling trips, between 1 and 2 weeks for each trip, across 3 years. Whereas we put the song meter at the same selected site, but only up for a year. And we set the song meter to record on a daily basis between from 6 o'clock in the evening till 5 o'clock in the mornings. So the hypothesis of the study was that passive acoustic monitoring will be a more effective or cost-effective and efficient monitoring tool compared to traditional surveying methods. So the materials and methods, as I mentioned before, we selected a single pan, and that was where the study took place. We used active sampling, pitfall traps, bucket traps, and dip netting, and the sampling trips were 5 sampling trips for the traditional methods. Then the passive acoustic monitoring, what we used is 1 song meter in a protective casing so that a rhino doesn't come and break the microphones off. And a solar panel was attached to this, as well as several SD cards for the recordings, and this was changed throughout the year. We used 1 tree to secure the song meter with a cable, and 1 me to analyze all the data and put up all the instruments. So there's just the setup. There is the song meter in its protective casing, and the battery source, which is connected to a solar panel. You can see the solar panel just sticking out above the tree line. And this is the temporary pan that we used for this study. Okay, in this temporary pan, over the course of 3 years, we found a total of 22 different species. The ones marked in green are the species that we encountered through active sampling methods, and that totaled to 11 different species. With the passive acoustic monitoring, over a year period, and utilizing only 1 day a week. So we didn't even look at all the data from every day that we recorded. Just utilizing 1 day a week, we encountered 20 different frog species. And then these 2, Schismodoma carrions, the red toad, and Xenopus mulleri, were not picked up by the song meter, but they were picked up through the traditional sampling methods. The reason for this being is that Xenopus calls underwater, so you can't hear it. And then Schismodoma is also known to call throughout the day. So this could be, or we could have just missed it in one of the days that we didn't check. So this just shows you that you could bump up the analysis looking at each day, as well as recording throughout the day. And we could maybe add species such as the edible bullfrog to this list, and other species that call throughout the day. So that's just for future work, and we learned a lot from this pilot study. Then this is just to show you the basic things that can be done with the passive acoustic monitoring. This is the data that we got from a year, from April 2013 to April 2014. Yeah, you can see in the winter there was no species that were recorded through the passive acoustic monitoring. And they started in August, a few species, or 1 species, and it slowly picked up, and in December up to 9 species in a single evening calling. So this just gives you a basic overview of what is possible with passive acoustic monitoring. Then this was just zoomed into one night. I just selected a random night. The 4 different frog species that were calling, and yeah, you can see the chiromantis started calling from about 10 o'clock and slowly picked up at sort of remained constant, and compared to Cassina senegalensis that started quite early in the evening, picked up and then slowly declined. Hemesis, it could this gap here could be that just in that 10-minute slot that we recorded, they maybe weren't calling. And then Takadina always starting late in the evening and ending quite early. So this was just one day, but if you really want to go into detail of the specific or of a focal species, you can determine its calling intensity throughout the evening, and getting a lot, like a month's data, and looking at it or over the breeding season and see when they prefer to call in the evenings or in the day. Then conservation implications. It's important to note that this is not a conservation tool, or it is a tool used for conservation, but it is a monitoring program. So you can only get data from this, and then you have to use that and implement it in your conservation and the questions that you want to ask. So with that, this tool can be used to monitor communities of amphibians in a specific area, and as well as the breeding activity can be monitored throughout the breeding season of a certain species or a community as a whole. And you can also work out the peak activity when a certain species is calling and when they really fired up. Call activity can also be combined with weather data, and this will be in the next talk they'll go into more detail about this. So this is also things that we can use in the future, is looking at rain data and drought and whatever, how this affects the calling activity and breeding activity of different amphibian species. And as Donovan mentioned, you can also estimate population size based on male calling, scoring out of 5, and working out, okay, so many males are calling, what is the estimate population density? And it can also be used as an aid or tool in a focal species, such as Donovan talking about the pickersgill, or whatever species you want to find out more about or conserve. Then disadvantages of traditional monitoring. I was just comparing the two. It's time consuming, it's laborious, it's often imperfect sampling, like missing a few species that are in certain specific habitats, or that are difficult to find or collect. Then it's relatively expensive if you're putting a whole team together and going on a research trip, as well as the timing. You're not always sure, am I going to get there while it's raining, or so that these are all disadvantages to traditional sampling methods. Compared to the passive acoustic monitoring also has a number of disadvantages. For one, it can be stolen, and it's expensive equipment. If you have technical difficulties, then you lose, and so now something goes wrong with your monitoring program while it's in the field, then you're losing a large amount of data. So this could be a disadvantage, as well as it requires expertise in the sense of you have to know what the different frog species sound like. And then you can only monitor one site at a time, and if you're using D-cell batteries, then it only lasts for a month. So that's why we use the solar panel. Then advantages of traditional monitoring is you're physically handling the specimen, and you're in the habitat, the microhabitat, so you're able to look at what possible threats and the health of the specimens that you're working with. You can also do additional research, as well as the field work. It's always nice being in the field. And then advantages of PAM is you're getting large data sets. It's a consequent technique. It's continuous measuring and flexible, so you can set it up to to answer a specific question in your research, and it also covers quite a wide range. And I think future studies will be used to determine what the range is in different habitats, urban as well as natural environments. And the data can be used for a number of different things. So once you have that data, you have it, and you can try different statistical analysis with that. And then it's also relatively safe in sites where there's crocodiles and hippos. You can set it up throughout the day, and it's covering quite a wide range. And then you can also focus on multiple species as well as focal. Okay, so my conclusion is that PAM, passive acoustic monitoring, is an effective monitoring tool for both frog communities as well as focal species, but I do suggest that it be used with traditional sampling methods, as you can't eliminate the human factor and professional opinion, and that is the problem with passive acoustic monitoring. It's not doing all that for you, and I don't think a machine can. And then future work is we plan to utilize passive acoustic monitoring in different ways, such as determining when a species, when the exact breeding activity of a species is, as well as answer more specific questions that are asked, and monitoring focal species, as well as call descriptions, and looking at the intensity and helping to determine population estimates. So, thank you.